Namaskar. Today's topic is producer gas. Producer gas is a gaseous fuel which is used in the industries for various applications, and it is mainly composed of two components, that is carbon monoxide and nitrogen. Yeah, simply we can say that producer gas is a mixture of carbon monoxide and nitrogen which is used for various applications in the industry. Fuel gas is generally prepared by passing a mixture of air and steam over a burning bed of solid fuel such as coal, coke, wood, or biomass. So, therefore, the carbon in this fuel gas is obtained from the carbon fuel such as coal and coke. Generally, coal and coke are used, and the instrument in which a producer gas is synthesized. This is known as gasifier, also known as gas producer. A general representative diagram of gas producer is placed below. You can draw this diagram also, right? Before going into the chemical aspect of the producer gas, that how the producer gas is synthesized, in this lecture we will be restricting to the synthesis of the producer gas, right? Before going into the chemical aspect, we will discuss that how this gas producer works, right? So this we can start from here. This is a chamber where pure coal and coke is placed. This is a pulley, right? When you pull the pulley, then coal and coke gets inside the gasifier. It gets inside the gasifier. In the gasifier, here is a grating. This grating does not allow any coal to go below this point, right? And when coal is introduced in the gasifier, after that air and steam, this is an inlet for air and steam. Air and steam is also introduced into the gasifier. And this is the actual place where burning of coal takes place, right? Now keep one thing in mind, that burning of coal or coke does not always leads to generation of producer gas. Producer gas is produced under specific conditions which are provided in this gasifier, right? Now coming to the gasifier, that how many types of reactions take place in this gasifier can be divided into three zones. First zone is the oxidation zone, from here to here. Second zone is the reduction zone, and third zone is the distillation zone. In the oxidation zone, oxidation reactions takes place. In the reduction zone, reduction reaction take place, and in distillation zone, some distillation type of reactions take place. We will discuss in this lecture one by one that what kind of reactions are taking place in these three zones which lead to production of producer gas ultimately. The producer gas does not necessarily contain only carbon monoxide and nitrogen. It may contain some other gases also, but the concentration of carbon monoxide and nitrogen is extremely high in that case. Therefore, the gas will be named as producer gas. Now coming to the reactions in the oxidation zone, right? I again want to repeat one point, that you added coal here, right? Then you added air and steam into this bed of coal, right? Now the coal will be burning over here. When the coal will be burning, the first reaction takes place in the oxidation zone, is oxidation of coal in the presence of oxygen and nitrogen. The oxidation reaction involves reaction of carbon which is supplied from coal or coke. I will write here the coal or coke, as it is the basic component for production of producer gas. Carbon will react with oxygen which is supplied from air. Nitrogen is also present in the air. It cannot be neglected because it contributes 78% of total air concentration, and it reacts to form carbon dioxide and nitrogen. Along with this, it releases some heat, right? Some heat is released, and the reaction is exothermic in nature. It releases heat, therefore the reaction is exothermic in nature. Now this reaction is an oxidation reaction. It is generally observed in our houses whenever you burn any fuel, whether it is a coal, whether it is coke or wood, right? This reaction takes place. The ultimate importance of this reaction is the generation of heat. The heat generated in this reaction increases temperature of the system, and when temperature of the system is increased, when temperature of system is increased, some other reactions start happening, right? And the other reactions, they happen in the reduction zone after oxidation happens. Now see, this reaction, as I told you, that the burning of coal takes place in the oxidation zone, and the reaction A is the only reaction which happens in this zone. Thereafter, when the temperature of system is increased up to 1000 degrees Celsius, the reactions in the reduction zone start. And the first reaction which takes place in the reduction zone is reaction of carbon with carbon dioxide produced in the oxidation zone. The carbon dioxide produced in the oxidation zone reacts with carbon present in the reduction zone, right? Now here do not confuse one with one thing, that carbon is present in everywhere in the gasifier due to presence of coal and coke. We are considering coal and coke as source of carbon, right? Carbon dioxide reacts with carbon to form two molecules of carbon monoxide, and the reaction is endothermic in nature. It absorbs some heat, therefore the reaction is endothermic in nature. Right? This is the second reaction which takes place in the gas producer during production of producer gas, right? Now here we can see that carbon has ultimately been converted into carbon monoxide, right? Nitrogen is already present there, carbon monoxide is already present there, therefore we get a significant amount of carbon monoxide and nitrogen, and significant amount of producer gas is started being produced, right? But along with this, here we are only discussing the reaction, we have only discussed the reaction of carbon with air. But coming to the gas producer, see here, along with air, steam is also passed in the gas producer, right? So carbon present in the gasifier has already reacted with air, but the reaction with steam is going to happen now, right? The first reaction which happens with the steam in the reduction zone is carbon reacts with water, that is steam, to form carbon monoxide plus hydrogen gas, right? And this reaction is again endothermic in nature. The second reaction which takes place with the steam is that carbon may react with two molecules of water to give carbon dioxide and two molecules of hydrogen. The reaction is again endothermic in nature. Now there is a difference between these two reactions, that the reaction C takes place above 1000 degrees Celsius. When the temperature is above 1000, the reaction C will take place. When the temperature is around 500 degrees Celsius, the reaction D will take place. Now note here one point, that the reaction D is producing carbon dioxide, but we do not need carbon dioxide in the producer gas. The thing we need is carbon monoxide. So the reaction D is undesirable. It is an undesirable reaction, and the undesirable reaction takes place around 500 to 600 degrees Celsius. Therefore, the temperature in the reduction zone should be maintained between 1000 to 1100 degrees Celsius, so that the production of carbon monoxide happens and no carbon dioxide should be produced. I want to mention here one more thing, that reaction B, which also happens in the reduction zone, this reaction also takes place above 1000 degrees Celsius. Therefore, the desirable temperature to obtain a good quality producer gas in the reduction zone is 1000 to 1100 degrees Celsius. Along with this reaction D, some other unwanted reactions can also start in the reduction zone if the temperature falls below 1000 degrees Celsius. The first reaction is the Newman's reaction, which involves conversion of carbon monoxide back into carbon dioxide and carbon. This reaction starts when the temperature is around 500 to 600 degrees Celsius in the reduction zone, and it should be avoided, right? Another reaction which starts is carbon may react with hydrogen to form methane. This reaction also happens around 500 to 600 degrees Celsius. Therefore, I am stressing this point again, that in the reduction zone, the temperature of the system should be maintained around 1000 to 1100 degrees Celsius, so that the reaction B and reaction C should take place to generate carbon monoxide. The reaction D and E are highly unfavorable because they lead to production of carbon dioxide, and it happens only when the temperature of reduction zone reaches to 500 to 600 degrees Celsius. Right now, these are all the reactions from A to F are all the reactions from in oxidation and reduction zone. Now, the reaction in the distillation zone. Note one point, that the reactions in the distillation zone take place only when the steam which is incorporated in the gas producer, right, it does all of the steam incorporated in the gas producer does not react in the reduction zone, right? If it does not react in the all the steam does not react in reaction zone, then it goes to the distillation zone, and the reaction in the distillation zone takes place. It means, see here, reaction C involves steam, reaction D involves steam. If the any steam is left, then the distillation reaction takes place. And the reaction in this reaction, the steam present in the water reacts with carbon monoxide to give carbon dioxide plus hydrogen. The reaction is slightly exothermic in nature, but it is not, its heat is not of much importance, right? So I'm telling you that carbon monoxide will react with steam. If excess of steam is added in the gas producer, then also carbon dioxide is produced, right? Now there are 2 points. First point is that the concentration of steam in gas producer has to be controlled, right, in order so that carbon dioxide should not be produced. And second thing is that the temperature of reduction zone should be maintained from 1000 to 1100 degrees Celsius, so that maximum concentration of carbon monoxide should be produced in the reaction. Right now at the end, these are the all reactions which take place in the gas producer. Now we have everything. We have got this nitrogen in the first reaction, right? We have got a lot of carbon monoxide from the reaction B and C. If the temperature goes somehow, the temperature goes below 500 degrees Celsius, that's small amount of carbon dioxide, hydrogen, methane are also produced. If the temperature remains around this zone 1000 to 1100 degrees Celsius, then the chances of production of carbon dioxide, methane, and hydrogen are comparatively less. Therefore, I forgot to mention in the introduction that the concentration, the type or quality of gas producer depends upon the conditions of the gasifier. Right? If the conditions of the gasifier means if the temperature of the reduction zone is maintained around 1000 to 1100 degrees Celsius, the gas produced will contain high concentration of carbon monoxide and nitrogen. If the temperature goes below 1000 degrees Celsius, it may contain some amount of hydrogen, some amount of methane, and some amount of carbon dioxide. So this is how the producer gas is synthesized in the industries. After the synthesis of this producer gas, the general concentration which is obtained involves carbon monoxide around 28%, nitrogen around 55%, hydrogen around 12%, methane around 2%, and carbon dioxide around 4%. But more is the concentration of carbon monoxide and nitrogen, better will be the producer gas. Now I want to discuss here one more point, that you can see these two reactions. The first two reactions are the reactions of carbon with air, carbon with oxygen, nitrogen, which is supplied from the air, right? In the first two reactions, we have already obtained carbon monoxide and nitrogen, right? And the producer gas is carbon monoxide and nitrogen. Then what is the need of adding steam into the producer gas, right? All these reactions c c d and f are obtained, are they these reactions occur when steam is added into the blast, right? When after steam so there is a importance of adding steam in the blast. Now it is not like that producer gas is only produced by passing air and steam, right? If you add air and steam, the gas producer is known as steam blast. These are all the reactions which are happening in the steam blast. But if you add only air in the gas producer, it is known as air blast, right? But there are some advantages of uh, adding steam into the steam blast. Into the steam blast, first advantage of adding steam is that, you see, only after reaction of carbon with the steam, hydrogen is produced, methane is produced. These hydrogen and methane, they increase calorific value of the gas. They have very high calorific value. So calorific value of the producer gas is increased due to presence of steam in the gas producer. Second thing is that, see, as I told you, that reaction A is happening in the oxidation zone. Oxidation zone is the lowest zone. It increases the temperature of the system, and this reaction may increase the temperature of the system up to 1500 to 2000 degrees Celsius, right? And we do not require this much of temperature for the synthesis of producer gas, right? In the absence of steam, only one endothermic reaction is taking place, that is reaction B, and reaction B itself is not capable of containing the temperature of the reduction zone up in this range, in 1000 to 1100 degrees Celsius, right? It means we require some more endothermic reactions. These more endothermic reactions are given by the reactions of steam, right? When steam is being added, the some more endothermic reactions take place. The energy released in reaction A is contained by the reaction B, C and D, and the temperature of the reduction zone is maintained around 1000 to 1100 degrees Celsius, right? So the second benefit of adding steam to the steam blast is that it helps in temperature control of the reduction zone, which improves quality of the producer gas. So that is it. So ultimately we came to know that there are these reactions happen in the during the synthesis of producer gas, and the producer gas can be produced in two ways: by using steam blast, by using air blast. In the steam blast, we add air and steam along with coal and coke, but in the air blast we add only air along with coal and coke. No steam is being added, right? But the quality and calorific value of producer gas obtained from the steam blast is much better than the quality obtained from the air blast. That is it with the producer gas. Thank you so much.